You're watching Channel Japan. Next, we'll be showing you a popular Japanese economics program, Gachiri Monday by TBS. Our topic today is fibers.
The first place we visited was the National Institute of Agrobiological Sciences in Tsukuba City. We were told they are conducting the latest research in agricultural technology. We had a researcher show us something he is working on in his laboratory.
これですね。
これ？
はい。
On the desk, there was a yellow skein of thread. It seemed to look normal. But then the lights turned off. And the thread started shining.
蛍光に光るシルクです。
The thread is made of silk. And it's fluorescent.
この蛍光シルクに関しましては、蚕が糸を吐く瞬間からもう色がついている。
最初からこの色？
そうです。初めからこの色の糸を蚕が吐きます。
Silkworms spin silk thread that are used for making their cocoons. Nothing is added. The thread is naturally fluorescent. Even the cocoons glow under fluorescent light. Even the silkworm itself glows.
蚕に、例えばクラゲとかサンゴの光る遺伝子を入れている遺伝子組み換え蚕だからです。
The thread is fluorescent because the silkworms are genetically modified. Some jellyfish and coral have genes that make fluorescent proteins. By combining these with the genes in silkworms, a worm that can spin fluorescent silk is created.
こちらで組み換え蚕、遺伝子組み換え蚕を作っているところです。
This is a laboratory for creating genetically modified or GM silkworms. First, the fluorescent genes from jellyfish or coral are inserted into a silkworm egg. The procedure is very difficult.
遺伝子組み換えを取るためには精子とか卵子になるところを狙って入れるんですね。で、ピタッと合えば組み換え蚕が取れると。穴を開けたり DNA を入れたりっていう操作は全て手作業でやっています。
Machines cannot do this type of work because the sizes and shapes of the eggs are all slightly different. A lot depends on experience and intuition. But even then, chances of success are only about 0.1%. Fluorescent silk threads are created in this way. Currently, the researcher and his team are working on commercializing this silk in scarves that shine in the dark or in wedding dresses to allow the bride to shine beautifully. They are aiming to have this fluorescent silk on the market in 2 years. But creating glowing thread is not the only research the National Institute of Agrobiological Science is involved in. They also have created a very strong thread.
これです。
これですか？
はい。普通のシルクに比べて切れにくさというものが 1.5 倍に上がっています。
Compared with normal silk, this is 1.5 times stronger at resisting being pulled apart. They used a gene from another type of living creature to make it.
この雲です。鬼雲と言います。
This is genetically modified spider silk, created by inserting the gene of a spider into a silkworm. Although extremely thin, spider's thread is well known for its strength.
1センチの太さがあったらジャンボジェットを釣り上げられるって言われてます。
Here's how strong GM spider silk is. Identical lengths and thicknesses of normal silk and GM spider silk are pulled to see which tears first.
いきます。
The experiment starts. The stronger of the two threads will resist tearing and will stretch farther than the other. The normal silk broke first, but the spider silk hasn't torn yet. 5 seconds later, the spider silk breaks.
クモの糸の遺伝子を預かうというのは非常に難しくて、まずクモから取ってくるのが難しい。で、取ってきた遺伝子を大腸菌の中に入れて増やすんですけど、それも難しい。遺伝子をいじるのが非常に難しい。
Normally, genes of animals are composed of various substances linked together, and those substances determine the properties of the genes. However, the genes for spider's thread have the characteristic of being rather repetitive in their arrangements. Despite being rather simple, decreasing the number of genes in these arrangements or adding to them easily corrupts the properties you want to obtain. Because of this, it's well known among researchers that using spider genes is very difficult.
だいたい10年くらいかかってますね。
10年。
はい。やっとここまで来ました。
Spider thread silks used for areas where strength is needed and where natural fibers are preferred, such as suture thread for surgery. It's also used where strength and light weight are needed, like parachutes. This GM spider silk promises to play a major role in a variety of areas. We next visited the Industrial Technology Center of Fukui Prefecture.
この糸のことですね。粒々が見えるかと思います。これが非常にすごいんです。粒々がですね、一個一個太陽光発電する素子になっています。我々はこれを太陽電池糸って呼んでいます。
Each of these 1.2 millimeter black grains is a solar cell.
これがその太陽電池糸を横糸に織り込んで作った太陽光発電テキスタイルです。
It's fabric that can make electricity in sunlight. When the researcher actually shines light on it, a voltmeter attached to the fabric responds. It's definitely producing electricity. If he takes this piece of cloth and connects it to an LED, the LED turns on. Here's what puts his hand over it.
光がありませんから発電しなくなってます。また手を外すと発電するかと。
If you take a close look at this solar cell thread, you can see that the tiny black solar cells are sandwiched between two threads. These threads, referred to as conductive threads, enable electricity to flow through the solar cell thread. The tiny amounts of electricity made by the solar cells accumulate, making the electric current stronger. These conductive threads are very important.
一個一個の太陽電池がちっちゃいんで発電する電力も少ないんです。でそれを流す時に電気抵抗が高いと全部そこで熱に変わっちゃいますんで電気抵抗の小さい糸を使っています。
This piece of fabric was made using solar cell threads.
薄くて軽くてこう自由に曲げれるというところが特徴ですね。テントとかそしてからカーテンとかアウトドアスポーツ系ですね、そういったところではどんどん使ってもらえることになるんじゃないかなって期待しております。
It could be used on greenhouses where heavy solar panels cannot be used. It could also be used in collapsible sails for ships. He says he'd like to have it for sale within the next 3 years. There's no limit on what this fabric can be used for. We next went to central Tokyo, to the headquarters of this company.
これはですね、ベルオアシという糸です。とにかくですね、吸い込む力がすごいんですね。
They have a flat square of this thread. It is put into a petri dish containing water. And then, the water is rapidly soaked up. In no time, all of the water has been completely soaked up. Compared with typical threads, the thread has an uneven surface, resulting in each thread having 50% greater surface area. Unlike the polymers used in diapers, these threads contain fibers that can be restored after drying them. Next, we were shown the cushion that was made using a new type of thread called V-lap. A comparison was made with an ordinary cushion. A piece of plate glass has been placed under the ordinary cushion and another piece under the cushion of this thread. A 2-kilogram iron ball will be dropped on the cushions from the height of 20 centimeters. The glass under the ordinary cushion cracked. As for the thread, there was absolutely no damage to the glass. Here's why it's able to protect the glass. The threads cling to one another, acting like pillars that reflect back the impact energy of the iron ball. This is a bottom futon mattress made using the thread. Its cushioning properties are similar to that of urethane. It possesses both lightness and breathability. This company makes many types of thread. One of them is quite amazing.
ナノフロントという糸を開発しました。
This is a pair of socks made from the thread. Just glancing at them, they look like a typical pair of socks. But if you zoom in and then magnify the view several hundred times, the material that earlier appeared to be single threads woven together is actually strands of the thread. A single strand is a collection of about 6,300 threads. This is the thickness of the thread compared with a single hair.
滑りにくいというメリットがあります。
In the case of a normal thread, only a small portion of it comes in contact with the surface it touches. But a strand of extremely fine fibers of this thread makes contact with the surface at numerous points. As a result, the frictional force of the thread is 3 times that of a normal thread, making it very resistant to slippage. It is used in shoestrings that don't come unloose, even when subjected to intense movement.
We hope you enjoyed today's show. Well, that's it for this edition of Channel Japan. There will be more on the latest information from Japan from our studio here in Tokyo, so join us again next time.